Science and Technology, Faculty of Science. My name is Edrisa Mugampoza, the Dean, Faculty of Science, and I'm going to chair this session, the defense, Mr. Manano. So the program remains, registration is ongoing. So whoever comes, please register your name, signature with the Secretariat. And then the next item is my brief remarks, very brief. And then we shall have a presentation by the candidate. That's Mr. Manano John. Then we shall give an opponent the next slot to engage the candidate. The opponent is also my former lecturer, so I don't know whether I can say, I will not give you time, how much time you should spend. Maybe I'll put that to you. Then we shall have to engage the candidate with other panelists whom I'm going to introduce to you. And then we can give a chance to the public, physical and online, to ask a few questions. And then we shall have a closed session by the panelists. And then later on, after that session, where we shall take a decision, we'll call back the candidate and any interested members, the public, to communicate the decision of the panel. So essentially, that is the program. Colleagues, I'm using the word panel, but the universal guidelines require us to use the word opposition committee. Not to scare the candidate, but that is the term that we shall be using for purposes. So my secretariat reminds me that we need a prayer. We have a sister. I don't know whether she will permit me. I want to sanitize this microphone to lead us in the prayer, and then I continue my communication. Thank you. Sister, the microphone is coming to you so you can say something as we lead the prayer. We want to move a motion to adopt the... Yes, sister.
I was wondering that in your briefing, are you going to give us ground rules? Ground rules like how many minutes is the student presenting and how many minutes is the candidate going to?
So we shall guide on how long the presentation is going to be, and maybe for the panelists, we are not very rigorous or very stringent on how much they should spend asking. But I'll guide on that as well. The prayer.
Okay, colleagues, as I am praying, if you are a Muslim, please call Allah. If you are a traditionalist, you can call Creator. And if you are a Christian, you can call God. Okay, let us pray. In the name of the Father, and of the Son, and of the Holy Spirit. Father God, Father Son, Father Holy Spirit, we want to thank you this morning. We praise you and glorify your name, Father, for enabling us to be alive. We want to thank you, Father, that we are the people you have selected to come for this defense. Father God, we want to thank you for our candidate who is before us here. We are here because he is the reason. I want to thank you for the graces. I want to thank you for all that you have offered him to come to this end. Father God, I pray that you work with him this morning. I'm committing him to the Holy Spirit, and I'm committing everyone here to the Holy Spirit. As we discuss, as we share, we do it for the glory of God and for the good of the society. This we pray through your name, Lord Jesus Christ. In the name of the Father, and of the Son, and of the Holy Spirit.
Thank you, Sister Kawa. Share the mass. And Director Quality Assurance. Thank you so much for that prayer. So colleagues, ladies and gentlemen, we continue briefly. I would like to take this opportunity to introduce to you the opposition committee, which comprises of Professor Achille Ukaya. I don't know whether he's going to raise the hand or whether people for recognition. So Professor Kaya holds a PhD in food science and technology from Virginia Polytechnic and State University, USA. It was actually a sandwich with Makerere, so he holds it from both places, Makerere University and USA. He also holds a Master of Science in Post-Harvest Technology from the University of Florida, USA, and a BSc in Agriculture from Makerere University. Now, for over 30 years, he has been teaching and conducting research at Makerere University, as well as community engagement within and outside Uganda. He's a former head of Department of Food Technology and Nutrition. That's from 2011-2019. And was also Deputy Dean, Faculty of Agriculture from 2009-2011 at Makerere University. His main area of work have been post-harvest technology, food safety, and nutrition, where he has published over 70 papers in referred scientific journals and book chapters. He has supervised to completion 9 PhD candidates or students and 26 MSc students. He has been a PI and co-PI of over 50 international research projects that, I beg your pardon, he has been a PI and a co-PI of over 50 international research projects which have generated scientific data that has been used in national development. He has also presented in over 100 international meetings. So in 2018, he was the winner African Union Agent of Change for aflatoxin control in Africa in the category of research and technology. And in 2016, he was appointed Fellow of Uganda National Academy of Sciences. He has been external examiner for 5 PhDs and over 20 MSc theses and dissertations. Lastly, Prof. Kaya chairs a number of committees in the country and belongs to 4 active professional bodies. He's the head of Laity, Gayaza Parish, Asanga Town Council, Wachiso District. A round of applause for our opponent, Professor Kaya. Heavy the fortified CV. You're welcome, sir. So other panelists, colleagues, we have Dr. Phoebe Kadu Mukasa from the Department of Food Science and Technology and an intern examiner. The next one we have Dr. Santa Maria Asio, Head of Department, Biological Sciences, Kyambogo University. I should have started with the director. I need to really apologize that. I don't know how it jumped my eyes. Directorate of Research and Graduate Training, Professor Bosco Boer. Then we have myself, the chair, and I was also an intern examiner for the candidate. Applause. And lastly, we have Madame Evelyn Nyamahunge, who is in charge of the secretariat table. Where are you, Evelyn? Ah, there she is. Then I'm reminded, I really need to apologize. We have Dr. Sarah Nanyonga, because you should be 7 panelists. Dr. Sarah Nanyonga is the head of the Department of Chemistry. She's a panelist. So we also have supervisors. I saw Professor Bazirake Biarugaba, George William, we all know him, and then Professor Ogok Patrick, backbencher. Then, ladies and gentlemen, in a special way, I would like to recognize the following categories of people who may be here with us or online. Members of the Governing Council. Dr. Jambo promised to be part of this session. I don't know whether he's between the council and here. Number 2, the members of the university top management, and then the senior members of staff, ladies and gentlemen. We really appreciate your participation. I would also like to welcome the online audience. I hope that audience is active and should be recorded as well as part of the proceeding. So in principle, supervisors are not allowed to speak during this public defense unless the committee, the opposition committee, requests you to seek clarification on certain issues raised by them. Now, I would like to end by strengthening the candidate that this panel here is not here to fight. Although the name sounds like opposition, but we are not here to fight. But essentially, we are here to listen to you. We want to share your understanding. We have read your book. We want to share your understanding of the book with our understanding so we are not here to fight. And so don't take us as enemies. Essentially, we want to understand what you did. We hope the way you understand it is the way we understand it. Colleagues and the public, you will excuse me. I need to apologize lastly for not mentioning Dr. Samuel Gafuma as one of the 7 panelists. Sam, you may have to wave your hand for recognition. Sam here is representing the head of Department of Food Science and Technology, who reported to work this week on Tuesday. He has been acting in that office, and the department agreed to recommend him to be part of this panel. Apologize. Now I take the honor to invite Mr. Manano John for the oral examination of his thesis. And Mr. Manano, you'll have 45 minutes to share with us your research findings. Thank you so much. Don't kill the can. Spread it.
Esteemed opponent, the panelists, online viewers, people present here, ladies and gentlemen, I welcome you here and say good morning to you all. My name is Manano John, a PhD candidate, here to give you a public defense of my thesis with the title, Rheological Characteristics of Wheat-Cassava Composite Flow and the Quality of the Composite Bread. The presentation outline is as shown. We'll start with the introduction, materials and methods, results and discussion, conclusions and recommendations end that session. The introduction. Rheology is the study of deformation of substances under applied force. Rheological technologies are very important in bread making, and it gives an insight into the quality of the finished product. Dough is an elastic material. That's why we use rheology to study it. When stressed as a viscoelastic material, some of the energy is dissipated as the material returns to itself in a non-equilibrium state. The behavior of the dough depends on the composition of the dough, whether it is blended or unblended. Composite flours, which is being used in this study, is a blend of different flours In our case, it is a blend of high quality cassava flour and wheat. The use of composite flours in baking utilizes local raw materials to produce quality products. The result, therefore, will mean reduced importation of wheat, and that can save this country some foreign reserve. In this study, cassava roots were used to produce the high quality cassava flour. Since we say the composite is between high quality cassava flour and wheat, then what is wheat? Wheat is a cereal of the grass family, is a member of the monocotyledonous family called Graminae. Wheat is used in bakery because it contains special proteins, glutenins and gliadins, which when hydrated form gluten, the most essential protein structure in all baked products. The proportional relationship between gliadins and glutenins is very important in controlling bubble growth and rupture in bread making. Cassava is scientifically known as Manihot esculenta crans, is of the spudge family. It's a perennial woody shrub grown for its tuberous roots, consumed in Uganda in many places, if not all over the places. I think only Karamoja, maybe Kapshorwa and Kigezi does not grow cassava. Many varieties are grown in this country. The names may differ, but the genes have not been studied actually to show the differences. So we have the improved families which come from our research institutions. We have the Nase family, which have been here from Nase 1 up to, I don't know, Nase 19 or 20. Recently, there were introduction of Narocas 1 and Narocas 2. Then we have some local varieties here, Okonyolada, Nyaraboke, Sokari, Chiwoko. According to Ogwal and fellow researchers, Nase 3, Nase 4, and Nase 19 among the improved varieties, and Nyamatia and Nyarokesha among the local varieties are the most grown in Nepi district. Cassava is also the second most important food crop in this country after bananas. It has technological potentials as a low-cost material in the food, pharmaceutical, textile, plywood, and paper board industries. It is also used locally to produce what we call waraji or gin. Industrially, it can be used to produce ethanol, as is being done at Camtech in Lira. And as an adjunct in beer, for those who enjoy some beer bottles for one for the road, there is Ngule and Senator from Uganda breweries, Eagle Lager from Nile breweries. Apart from using it locally here, Uganda is also a major exporter of cassava in the Great Lakes region. This is one of the varieties, Nase 14, which is most grown in the Nepi district. And we have how cassava is going, the trends. Differences in the trend may be due to different things, diseases, loss of trust because there is no market for your product and people go to something else. So Uganda is an important player in the export market, exporting fresh, chilled, frozen, and dried roots and tubers. The major export partners are Canada, Burundi, South Sudan, Kenya, Democratic Republic of Congo, and Rwanda. The export figures have been increasing since 2012 and 2018. Now, ladies and gentlemen, you would understand how important or reminding the closure of the Rwanda border meant for our export things. So this is the trend over the years. Problem statement. Despite the high value or volume of cassava produced, there is very little value addition to the crop. Over 60% is consumed at home as in the form of flour to make ugali or in the fresh form. There is very little utilization of the better varieties. Information of the composition of flour obtained from the different varieties are very meager. In Uganda, production and utilization of high quality cassava flour in bread is still low, and the technological behavior of high quality cassava flour wheat composite is still limited. Justification of the study. The data obtained could be used in planning the cassava chain value. Here policies will be there. Partial substitution of wheat with high quality cassava flour could lower production costs of baked products and make bread affordable to low-income earners. Use of high-quality cassava flour could lead to product diversification and increase utilization of cassava, promote cassava growing, hence leading to enhanced incomes for farmers. So we have already talked about the value of cassava as an export commodity. That was another thing. This is wheat export. Objectives. The major objective or the general objective is to assess the potential of wheat cassava composite flour. In this case, the cassava in wheat is the high quality cassava flour as an industrial raw material for bread production in Uganda. Specific objectives. Objective number 1 is to determine the proximate composition, mineral content, and contents of anti-nutritional compounds of high-quality cassava flour produced from the roots of sweet, the improved NASE 3, NASE 14, NASE 19, and the bitter Nyamatia and Nyarokecha cassava varieties. Number 2, the objective is to determine the physico-chemical characteristics of high-quality cassava flour obtained from the roots of these selected cassava varieties. Objective 3 is to determine the rheological characteristics of wheat, high-quality cassava composite, and the composite, the high-quality cassava flour being obtained only from NASE 14. Then to assess the qualities of the composite bread and correlate the qualities with the rheological characteristics of the composite dough. Hypothesis. Number 1. There are no differences in proximate composition, mineral content, and anti-nutritional content among the high-quality cassava flour of the selected cassava varieties in this study. There are no differences in the physico-chemical properties among the high-quality cassava flour of the selected cassava varieties again. Incorporation of high-quality cassava flour into wheat does not affect the wheat's rheological characteristics and the quality of the resultant bread. Number 4, there are no correlations between the quality of composite bread and rheological characteristics of the composite flour and dough. Materials, roots of improved varieties. These are NASE 3, NASE 14, NASE 19, were obtained from an official Zardi seed farmer. The local varieties, Nyamatia and Nyarokecha, were bought from farmers in 3 sub-counties in Nebi, Kushuin, and Parompa sub-counties. The wheat from Bakresa with the brand Azam was purchased from local stores. Other ingredients, sugar, shortening, salt, nutmeg, and instant yeast were also purchased from local stores. The methods, sampling and sample treatment. Here, purposive sampling was used based on a survey from Ogwal and colleagues. The 3 mature cassava plants were in each case selected randomly from a farm or a garden. The harvested roots were inspected for any signs of diseases, which can be done by lay people. Roots of the same variety from the same field were composited into one sample and packaged in polythene bags. And they were labeled and transported to Kyambogo University Food Chemistry Lab. Production of high quality cassava flour. Roots were peeled, grated, and dried at 50 degrees for 24 hours in a hot air oven. The cassava chips were cooled to ambient temperature. Dried cassava chips were packaged in clean, dry, high-density polyethylene bags. The bags were stored under cool, dry conditions, waiting for analysis and utilization. Prior to analysis, the dry cassava chips were ground to powder. The resultant cassava powder is what we call high-quality cassava flour. This is the production process, what I talked about here. Determination of the proximate and mineral composition. Proximate composition, that is moisture, protein, lipid, ash, fiber, and carbohydrates, were determined using the AOAC official methods of analysis. Total starch was determined on a UV-vis spectrophotometer using anthron reagent at wavelength 630 nanometers. The minerals, calcium, zinc, iron, magnesium, and copper were determined on a Pekin-Elmer atomic absorption spectrophotometer using AOAC method. Determination anti-nutritive factors. Cyanogenic compounds were determined using the alkaline pyrite method based on Bradbury and colleagues. Phytate was determined using the anion exchange method explained by Ma and colleagues. Oxalate was determined using the titrametic method as explained in Adeni and colleagues. Tannins were determined using the Follin-Denis method as explained in Makar. Determination of the physicochemical properties. pH was determined using an electromic pH meter based on procedures of the AOAC. Total titratable acidity was determined by titrimetry, also based on AOAC method. Swelling power and the water binding capacity was determined as the weight ratio of sediment or pellet to dry flour based on AACC, that is American Association of American Cereal Chemists standard method. Water solubility was determined as the weight ratio, also based on AACC method. Formulation of wheat-cassava composite. Up to 40% cassava inclusion in wheat cassava composite flours and bread has already been reported. For example, in Sieni and co-researchers, Jensen and co-researchers. Also, the East African standard, EAS 740 of 2010, recommends a minimum of 10% high quality cassava flour by weight in composite flour. Therefore, wheat and cassava flour composites were formulated in the ratios shown. 10 to 0, that's 10, 100%, 100 to 0, 100% wheat, 0% cassava, and it is used as the control. Up to 40 wheat, 60 cassava. Rheological characteristics determination. Indices of absorption, mixing, gluten plus, viscosity, amylase, and retrogradation were determined using the Amixolab 2 of shopping technologies. The viscoelastic parameters, tenacity, extensibility, ratio of dough tenacity to extensibility, swelling index, deformation energy, and elasticity index of the composite flows was determined using the Alveolab, also from shopping technologies. The water absorption capacity and maximum pressure were determined also by Alveolab from shopping technologies. Determination of the physical attributes of bread. Bread was made using the straight dough method. Loaf weight was determined using digital balance according to ACC method. Bread volume was determined using a modified rapeseed displacement method. The modification was in the use of millet seeds rather than rapeseed. Water loss was determined using the weight differences between weight of dough and weight of the loaf. The data were used to determine the specific volume and density of the bread. Sensory evaluation. The 9-point hedonic scale was used to rank bread for crust color, taste, crumb texture, according to Lawless and Heyman. The overall acceptability of bread was similarly determined. The data were subjected to analysis of variance using SPSS version 23. Least significance difference test was used to separate means, and significant at the probability of 0.05 confidence. Relations among variables were evaluated by the principal component analysis using XLSTAT version 2.2. And results. Proximate composition of high quality cassava flour obtained from roots were analyzed for moisture, ash, crude fiber, crude protein, crude lipid, and total carbohydrate. In between, we also got the starch as is part of the carbohydrate, but it was necessary to get it separately. From the results, we also analyzed the minerals, calcium, iron, zinc, magnesium, and copper. Levels of anti-nutritive factors were also analyzed. Key observations. The ash and protein contents were higher in the high quality cassava flour from improved cassava varieties compared to the local. Nyamatia and Nyarokecha are local varieties. These are the improved varieties. These are the local varieties. So we say ash content higher here generally. There they are lower. Crude protein is higher in the improved compared to the local varieties. Second observation, the fiber contents of all the high quality cassava flour were higher than the recommendations of the East African standards, which is 0.02. Crude fiber, all there. The standard says it should be not more than 0.02. Iron content was exceptionally low in high quality cassava flour of all the selected cassava varieties. And the high quality cassava flour from the beta varieties had higher cyanide content. Highlighted there. Nyamatia, Nyarokecha. Physicochemical characteristics of high quality cassava flour and wheat. We have the pH, water binding capacity, swelling power, solubility, total treatable acidity. Key observations from the physicochemical measurements. pH of all the high quality cassava flours were above 5.5, indicating low levels of fermentation. And the East African standards also puts the pH of high quality cassava flour to be not less than 5.5. Higher water binding capacity of the high quality cassava flour were higher than for wheat, but the solubility of high quality cassava flour was lower than that of wheat. There was a general low total treatable acidity similar to that of wheat flour, meaning there was very little acid in the high quality cassava flour. Rheological characteristics of wheat, high quality cassava composite flour. The parameters measured here were water absorption, mixing, gluten plus, viscosity, amylase, and retrogradation as fixed by the machine. The Mixlab 2 machine also measures dough rheology in terms of dough development time, apart from water absorption, dough stability, protein weakening, starch gelatinization, stability of hot form gel or an amylase activity, and starch retrogradation. This is the result based on water absorption, dough development time, stability, and the rest which we have said. Alveolograph parameters, as we have stated, measures pressure, that is elasticity expressed in terms of pressure. It measures extensibility shown by the letter L. Here is elasticity, extensibility. This is the ratio of elasticity to extensibility. Expansion index, the energy or work done on the dough during the kneading in the measuring machine. This is elasticity index. The consistograph measures the parameters water absorption represented by WAC, and also pressure represented here, PR max, measures in millibars, or sometimes recorded as millimeters of water in the measuring component. Key observations from those measurements. Significant differences were observed between wheat high quality cassava flour composite and wheat flour at 20 and 30% inclusion of high quality cassava flour for amylase index and retrogradation.
I've been requested to pause the presentation a bit until we are sure we are safe. I think it's not a strike, I hope. Let's check. We are timing you, so you still have 18 minutes.
Thank you, Chair. I was here explaining the observations that rheological characteristics of wheat high quality cassava flour differs at 30% inclusion in the composite. And the major problem here, where there is disparity at 10 and then 20% inclusion, is based on amylase index And at that, 20 is based on Rheological index. And amylase, the amylase index refers to the resistance of starch to hydrolysis. The higher the amylase index, it means the starch is more resistant and it will be contained more in the final product. And retrogradation index also indicates that the higher the retrogradation index is, the lower the hydrolysis of the starch. So in the final product, we have higher starch, which means the product shelf life is reduced. Another observation was that there was a significant difference in the mixolar parameters of high quality cassava, flour, and wheat at a inclusion rate greater than 20%. And tell you that there was no clear trend in alveograph and consistograph measurements. There is no clear trend here. Everything is different. The subscripts show things are different. Here, though, that is for consistograph. For alveograph, is the same story. Elasticity of dough does not change in a consistent manner with the inclusion of cassava. Extensibility of dough does not change in a consistent manner. That can be explained by the addition of cassava flour. And the ratio in the name way and all the rest. So there is no consistency which can be explained. Sensory attributes of bread made from the wheat high quality cassava flour composite. We were interested in color, taste, crumb texture, and then there is the overall acceptability. From this study, we can see the crust color only started scoring lower than 5, which is the midpoint score on the hedonic scale at 30% inclusion. But statistically, this, if you add 4.88 to 0.99, it would give a score greater than 5. So actually, the crust color would not fail at all up to 40% cassava flour inclusion in our composite. When we come to taste, it also differs at 20% cassava flour inclusion. But again, statistically, if you add 4.88 to 1.46, you have your score greater than 5, which gives you a neither acceptable nor denied the chance. So you could say actually at 30%, we could produce bread which could be acceptable, since actually it scores even at 5.5, which gives it a chance to be acceptable. The same with the 40%. At 40%, the crust color was given a good percentage, above 5. But the taste was the problem here. But again, statistically, if you add 4.63 to 1.69, you get a taste score of greater than 5. And 5 is a neutral score, which means it is neither good or bad for the panelists who are testing it. The crumb texture was good up to 40% cassava flour inclusion in the composite. And total acceptability also showed that actually we can put up to 40% cassava flour in the wheat composite to produce acceptable bread. These are the key observations which I have explained. It is now to relate those values of sensory evaluation to the rheological characteristics measured by our equipment. Let's look at this quadrant here. We take crumb texture. Crumb texture is affected by elasticity, which is P, here, elasticity, for those who have forgotten. We have dough development time, starch gelatinization, viscosity, and the fact that these vectors are close to crumb structure or texture, which is our attribute of interest, means that they affect crumb texture. How does dough development time affect crumb texture? Dough development time is dependent on the flour type. A longer dough development time means the flour is hard. Hard means it has a good protein content. Good protein means the glutenins and gliadins are there to form gluten, which can give us enough extensibility to allow the incorporated air and the carbon dioxide produced by yeast during fermentation to be accommodated without the dough exploding and giving a good oven spring when it is being baked. Retrogradation, how would it affect our stamp structure? Retrogradation is mostly dependent on the starch content of the flour. Starch will combine the amylose and amylopectin with the time when the bread has been baked and it is cooling. With the time it gets cool and the structure comes back, the effringence is recuperated and the bread gets hard, what we call staling, which is bad for business, is bad for sensory attribute, but at the same time, I always insist that without retrogradation, there would be no bread because the crumb has to set. So there is a level of retrogradation which is important in our bread. If we looked at crust color, we are looking at retrogradation again, amylase, PR max is the maximum pressure measured by consistograph, and it shows elasticity. Any bread or any flour which is very elastic will want to come back after the dough has been made. It will never allow air or the carbon dioxide produced during fermentation to expand. So the volume of the bread produced is small and the density will be high, and that affects the texture. Now, when it comes to amylase, how does it affect crust color? Amylase, I hope we are all scientists here who can basic teaching for P5 enzymes in our digestive system. It breaks down carbohydrates. If amylase is in great quantity, it will break down our starch during dough formation, which will produce low dextrins, oligosaccharides, and mono and disaccharides. Those small sugars in the presence of heat will react with the available amino acids to produce us the brown color we enjoy so much due to the process called Maillard reaction. At the same time, when the moisture content goes down at the surface of the bread during baking, there is caramelization. The sugars produced as a result of amylase activity hydrolyzing starch produce for us the caramels. The color and the taste of all those give us the crust color and the taste. The key observations we have made from the principal component analysis. Okay? We have acceptable quality up to 30%. That may up to 30% here at the crossroad. It is slightly in a negative section, but it could be there, 30%. But at 20, 10, and 0%, we have bread of acceptable quality here. As we go more, the bread density, the loaf increase, and it becomes tight. Conclusions. The mineral content of high quality cassava flour was generally low, implying that cassava is a poor source of minerals. Sorry. High quality cassava flour from all cassava varieties are total cyanide and phytate above permissible limits. High quality cassava flour from sweet and bitter cassava roots have a higher water absorption capacity than wheat flour. Partial substitution of wheat by 20 to 30% high quality cassava flour is feasible based on the mixer lab measurements. Up to 40% substitution of wheat by high quality cassava flour is feasible based on sensory evaluation recommendations from the study. High quality cassava flour in combination with wheat flour can be used in bakery. Fortification of high quality cassava flour with the zinc and iron is recommended if it is to be used in bread. The mixer lab parameters could be used to predict the quality and quantity of wheat, high quality cassava flour, composite flour in bread making. There is a need for further research to design processes for high inclusion levels of high quality cassava flour in the composite bread. By process here, we mean either getting additives, flour improvers, or changing the regimes of operation. How long do we mix or when do we add the cassava flour to the wheat flour in the composite? There is also need to establish shelf life stability of wheat high quality cassava flour composite bread. Differential scanning, calorimetry may be used. Diffusion, water diffusions, absorption, X-ray diffraction to see what happens in the bread, to see really what is happening during retrogradation. This research gave 2 publications. One was titled Chemical Composition of Major Cassava Varieties in Uganda, Targeted for Industrialization. The second was Rheological, Baking and Sensory Characteristics of Bread from Wheat Cassava Composite Dough. We have to acknowledge people and organizations which now help me here. Kyambogo University was responsible for the funding. The supervisors gave me good guidance. That's why I'm here talking with you today. Australian National University College of Science supplied or donated the Picret kit used for measuring cyanide content of the cassava flour. And Mr. Geoffrey Piero provided cassava varieties. He is the man for the Zardi in Navy. Thank you for your time.
Thank you so much, Mr. Manano, for that wonderful presentation. Allow me to acknowledge more protocol. I'm a Dean of Science. You can see almost all my heads of department present. I will not mention name by name. Now, what comes next after Mr. Manano's presentation is the question and answer session, which is going to begin in a couple of minutes. I didn't even thank you for sparing us 5 minutes. We've done this in 40 minutes. Well done. And we will have 3 rounds of questions. One from the panel or the opposition committee, then the physical audience, a few questions, and then our online audience. I think we want to start, as I read the program, with our opponents, engaging you for about 30 minutes. You're lucky that that should be less. So unlucky, slightly more. And essentially, I just want to ask specific questions about the thesis. I hope you came with a copy. And I pray that all the questions asked should be within the scope of research of the candidate. So we should have a microphone with the opponent. But as the opponent comes to engage you, I can ask a very quick one. Would you mind telling us what motivated this kind of research? Were you being very kind to the farmers of cassava, or there are other specific reasons?
Thank you, Chairman. What you see in me here, you are saying cassava itself. I come from a cassava growing area, consuming area, so that motivation to make sure that the cassava we eat is safe, that there is value addition to the cassava to make the farmers get something out of their sweat, and make the cassava more valuable for people. If only the chairman could give me time. There is this notion that cassava is only for poor people, which is not true, because I don't consider myself a poor man in the first place. Secondly, when they sell fried cassava strips from Banda, Okinawataka, some people who don't have a lot of money buy them, they bring them to our offices, but when they reach office, we want to have a taste. We say we are not poor, but we want to ask those we consider poor to give us a piece or two, and we start appreciating that they are nice. So the research is also intended to bring cassava to the mainstream of the people of this country. And thank you.
Thank you very much, Dean Prof. Mugampoza, for welcoming me, and also for appointing me as an opponent, which is a term that I have never liked to use in my life, because this guy may not even invite me for his graduation party. If he really thinks that I was an opponent, actually I think I should be regarded as a discussant. Protocol observed. Everybody, thank you very much for the support of Mr. Manano, and Mr. Manano, thank you very much for the nice presentation, and I hope this is the last time we shall be referring to you as Mr. Manano. Okay, yeah, let's now engage each other, and somewhere if you see my face change, please don't get scared. Now, I'll be giving, some of them will be just comments, and others will be questions for you to answer. The title, I read your thesis. Actually, I was the external examiner. I read it thoroughly and understood it very well. This is not a simple area, ladies and gentlemen, to work on, and I'm sure when he presented some of the results there, some of us probably were not even following, if you're not a true scientist. The title, first of all, I think you need to change it, because you are talking about rheological characteristics of wheat cassava composite flour and the quality of the composite bread. Two words, composite, I think don't have to appear in the same title. And then when I look at when you say and the quality of composite bread, the two seem to be separate. So like the composite bread was made somewhere, and then also the rheological characteristics of the wheat cassava composite flour were also studied separately. So find a term that can actually link the two to prove that the composite bread was from this particular flour. Then the abstract, of course, I read and found out that you are giving ranges instead of actual means that were established during the study, which I think that one also you need to see my comments in there, and you refer to it very well. The background, of course, was a little systematic, only that some statements were mentioned as if they were actually your own statements. And indeed, even in the presentation this morning, when you're presenting the background, there were many statements where you do not put references, but others you would put references. Maybe it's because you said that when we see cassava, when we hear about cassava, we see you, but I think you need to have supported those by, research findings. Now, the justification for the study. When did you publish these papers? Remind me.
The first one was, I think, 2018.
Huh?
And the second one was last year.
Last year.
Yeah.
Okay, have you now seen, because you gave several points of the justification. Have you seen anything that has happened since you started this study? According to what you predicted, that the results of the findings be used to A, B, C, D. Is there anything? Like now, data obtained could be used in planning the cassava value chain, all those, the way you put them, anything that has now taken place since you started publishing your information?
I got something in the process going on, but I did not get the results. That there was the AGRIT project, which was here, and they gave some organizations to produce composite products. But because they are companies, they are secretive with their things and they don't publish. Breakfast, equivalent of breakfast cereals. Is it Rufo or some? The Ministry of Agriculture and Animal Industry has those, but I tried to ask them what is the outcome. They don't give me.
Okay. Think about it. Now, objectives. Why is it that the objective now, actually most of your objectives have changed? Why? Like when you look at specific objective number 1, it is different, very different from what is in the thesis that I read. Why have you changed that objective? In fact, not only that, I think even maybe even the objective number 4, something like that, or even 3. Why have you changed your objectives?
After submitting the book, I was still going through the books again, and some information I felt needed some muscle addition, and to make somebody not ask so many questions. So, like in the book, the root, the varieties are not there in the book.
But you are using in the book, you are talking about cultivars.
Yes.
That was even going to be my next question, by the way. You are talking about the objectives are talking about cultivars. Then the other, all the other, mentions are about varieties. What is the difference between a cultivar and a variety?
Opponent, that is a very difficult and interesting question. As we refer to cassava, I got mixed up in the things because they said cultivar is cultivated variety. And variety, you get an offspring true to itself using the seed. Now I came to discover and know that with the cassava, you can either use the seed to produce another cassava or use the stems. So that is where the confusion is. Now, which cassava has been produced out of the seed and which one has been produced from the stem? So at the beginning here, I thought cassava, with regard to cassava, cultivar and variety can be used interchangeably because nobody can tell which is which.
I'm not so sure about that, but if I were you, I would stick to cultivar. Okay, now in that same objective, we talk about to determine the approximate composition, and one of the major components of the the components that you determined was the starch, and you did even mention that starch had to be separated, although it is a carbohydrate. Is it appearing in that objective number 1?
Here it is not.
Why? So if it is not in the objectives, why did you bother about it?
It came about when I was reading about the composition of high quality cassava flour as demanded by the East African standards. They wanted the starch of not less than 60%. And unfortunately, I did not come back to put it back there that I needed to verify it alone.
Okay, fine. I think you need now to rewrite that objective to reflect that important component. Now, the other issue that I found very strange in the thesis, there were no hypotheses or research questions. And now you have them. Where did they come from?
As I say, opponent, I read through again the book, and those are the flops I was getting in my own work.
I don't know. Now, do you think that is something that would have affected your performance? No? Because really, at the PhD level, having done a master's, how do you leave out hypotheses or research questions? So the objectives were based on what? That means you formulated the hypothesis after objectives. Anyway, that one I leave it to the panel to decide. And in fact, some of the hypotheses that you stated are quite obvious to me. I mean, very obvious. Like nothing being investigated at PhD level. So anyway, you need to revise those hypotheses. I will not go through them at this time. Now, somewhere, if we go to the literature review, I think one of the biggest challenges I found as far as the literature review was concerned was all those writing like 2 or 3 paragraphs without a reference, and yet that was actually a literature review. So I think there's a lot that you need to do in your thesis to put references, and also to make sure that at least paragraphs are separated and written clearly. There was a reference that I found of 1953. Reference of 1953. Be sincere. Did you read this?
Opponent, normally, I read the abstract. The body may not be there. Sometimes they don't allow us to open even. When I get the abstract and I get something interesting.
Because it was even written in French.
I think, I'm not sure which one, but the abstract should have been in English also.
Okay. All right, now, I think there was a major gap in the literature, which I want you to talk about. You never talked about rheological characteristics, and sensory attributes. At least you should have talked about the sensory attributes of bread, what is expected in the literature, so that when you're discussing, you actually compare with what has been indicated before. So also make sure that the references which are cited in the text are also in the reference list. Many of them were actually missing. And for me, when I see that, I become disappointed straight away. Now, you talk about, in the methodology, you talk about, first of all, screening the the roots, make sure that there were no diseases in them. I want you to give one example of a disease that you expected. And why only diseases? Don't you think there are other physiological characteristics of the root that would affect your results? And if you think so, give me an example.
What from that now empirical experience with the cassava, you can get cassava which is becoming woody. That can affect the result of the outcome. And there are certain things, there are certain diseases you cannot detect from the outside. Is it brown streak disease? You are peeling your cassava, but it's already inside there, and by the time sometimes you have already grated it also, that can become a problem.
What about vascular streaking? That physiological disorder?
That is what we try to avoid during the harvesting. No wounding of the roots.
Okay, I think you should have considered those also as important, rather than talking about the disease alone. Yeah, I think you should have looked at those as well. Now, you talk about okay, with the methodology I'm okay, but I want you to explain to me why you used those ratios, 90, 10, whatever that, because you tried to explain the 40% inclusion that is allowed.
Yeah.
Why didn't you use the 95 to 5, 85 to 15, but 75 to 25, but you use those particular ones? There's no any mention why you selected those ones.
In the book,
yeah,
there's no mention.
There's nothing. Yeah, why not 95 to 5 or 85 to 15, but 80 to 20?
In literature has it already up to 40%. Actually, recently, no, not very recently, in 2013, the IITA came up that they also produce a 40% wheat-cassava composite, and the then president of Nigeria, Jonathan, declared as a policy 40% inclusion. And you would look, it would be too much of a reputation. Oh, let me see, can I also do it? Because going through what they did, they don't give all the things they use, the improvers, the what, but here I did not use any other thing. It just...
I mean, I understand the 40%, but you look at 90 to 10, 80 to 20.
Those are all from literature.
They are from literature?
Yes, people have already done them. The only thing, 50, 60, I was just trying to exceed and see what happens, and I didn't get anything good out of it.
Okay, fine. Now, the results, according to what I saw when I read the results, you would not actually, example, if you found out that the moisture content is of this particular level, crude protein, lipids and whatever, we are of this particular level, you are not actually explaining why and what is the significance of these results. Why did you determine the minerals, for example? Why did you determine, protein? You found out that the lipid, content was low. Why did you determine the lipids? What was the significance of that? Apart from mentioning something about the East African standard, nothing actually is talked about, those levels. I think it is very, very important that you tell us why actually you decided to determine those particular components. Or you can, if you feel that, yeah, you need actually to include that in the book actually. Yes, maybe from the nutritional point of view or whatever. And one of the components was actually the lipids. You said that the cassava was very low in lipid content. Do you expect high lipid composition in cassava?
So I went as a naive person. I just wanted to know what cassava has, not with the preconditioned idea in my head.
Cassava?
I just, yeah, people in different, there was a time I was surprised. I was reading about cassava from South America. Somebody told me they have a cassava with 5% protein. And it shocked me.
Okay, now the composite flour. What varieties were used to make the composite flour?
I actually used one variety only.
Why?
I found that variety.
And which one? And why don't you mention so?
That was the mistake I made, sir. I used the NASE 14. Among the NASE varieties, I found that it had a little bit higher protein, about 1.5. Then I felt maybe that could give me some better quality in terms of nutrition compared to the rest. NASE 14.
Okay, please clearly indicate that in the thesis so that somebody who is reading will know where the composite flours actually came from.
Yes, I did.
You talk about, in the thesis, talk about inclusion of 40% cassava flour policy being, passed. Is that what you mentioned?
Yes.
40%?
In Nigeria.
No, you talk about Uganda.
That was a slip maybe of a pen or something. It is
page 113.
113?
Yeah. You have to cross-check that. Let's not waste a lot of time. I think that's a mistake. Please cross-check and find out. Okay. As a chairman, I'm about to finish. I don't want to roast this candidate too much. Now, in your abstract, you talk about the economic importance, of your study, and it's not mentioned anywhere. Did you carry out the economic value of incorporation of your cassava, the cassava flour into wheat? Don't you think it is important?
It is. I got caught up in the events. I know the price of high quality cassava flour. I did that small economics, but I was stuck because I looked at a miller having to invest in a mixture, employing somebody, and I could not get the full thing. But I should have actually maybe removed it from the abstract.
Yeah.
Which unfortunately.
Yeah, I think you need to remove it from the abstract, put it as a recommendation. Somebody at least carrying out or studies involving the economic value of incorporating, especially the recommended levels of cassava you have talked about. Now, why do you think your study is worth a PhD?
That is tougher than even the other one. So I'm just happy that I can give you some information to audience that yeah, our cassava here, you can add value to it and improve the conditions of farmers. You use it in other places based on some scientific thing. What and somebody wants to offer me a PhD is a bonus because the information will remain, and that would be good if you could give me a PhD for that. I would appreciate really.
We may give you a master's. Anyway, well, so what new knowledge exactly? Because if you are talking about getting a PhD, you need to provide new scientific knowledge to the wealth of knowledge that is already existing. What new knowledge has contributed to the wealth of, science right now?
What is important to me here, according to that question, is the use of Ugandan cassava varieties. The few, though, to show Ugandans that we cannot only read about what is happening in Ghana, in Nigeria, but we can use our local raw materials to produce the things those people are doing, using base, and the use of current scientific equipments to test things, like for rheology. In Uganda, I don't know how many places have this Mixolab equipment, but it's also an important thing to say that we can use Mixolab equipment to test qualities of cassava wheat composite, which I've not come across, and that would be something for us, Uganda and Africa, where we grow cassava, to use. I've not read anything from Nigeria about using it in their bread.
Okay, and lastly, why did you publish your findings in the same journal? Why didn't you diversify?
It would be a nice thing to diversify, but I hope people won't crucify me, sir. These publishers require money, and I didn't have enough, really. I tried. I was very much interested, actually, in the African journals, like the African Journal of Food Science and Technology. They ask $550, $700. You go to Europe, they're asking for $700 something, and the funds are not forthcoming, and it's tough. It's just unfortunate that we cannot afford some of those things.
Yeah, I'm not convinced for sure. I think you should have looked for another journal, which is there are so many and actually reputable journals to publish your work, because you are limiting yourself together with your co-authors, because this is the same thing. And like in the market, actually they wouldn't consider this to be different publications. It's one publication. So think about it in future. Okay, thank you very much, and yeah, that is it, ladies and gentlemen.
Thank you. Who should I thank first? Opponent, I think. For the wonderful questions, and to the candidate for the wonderful answers. Actually, you were saying that there was no money, but universities pays for publication. So you can't say that there is no money for when the director is here, he's going to say no, 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 no. They always approve. So that can't be an excuse that you didn't have money to publish. But maybe I can say that in the guidelines we follow, in the graduate handbook, we don't have any article which requires that candidate must publish in different journals. But I think it is desirable. So I think when we review this booklet, from where I'm picking this recommendation, we need to capture this. Thank you so much, and I think it deserves a round of applause. You will allow me to request the director, graduate training, to fire his questions, and then examiners can come on board, the intern examiners, and then the rest of panelists, and we proceed with the public as already informed. Have the mic.
Yeah, thank you very much, Chair and the Dean. And do I call you a Mogole? I call you what? What should I call you? I don't know. Thank you very much. I think we are here because of you, and we have enjoyed your presentation. What I would have asked, I don't know whether opponent had read my mind. All those things I've been writing here, but I will ask you some of them. One, I think I want to start with the last one. Publishing 2 articles in the same journal is actually going to have implication on your career growth. The graduate handbook may not have it, but now we have a new criteria for promotion, which I don't know whether you have read. Because if by good luck we decide to declare you from MR to DR, I'm sure the first thing you are going to ask yourself is, I want to be promoted. So we are going to look at those papers. And my question there is, did you check the credibility of this journal? The credibility. Because in the criteria for promotion, that is one thing they are asking, the credibility of the journal you are publishing. You have had colleagues here crying that they publish their papers from somewhere, they were awarded a PhD, but they have refused it here to promote them. So don't you think you are going to curse us? Much as you are saying there is no money. We have money in the Directorate of Research and Graduate Training. I think we had a meeting about 2 weeks ago. There's one staff who is in, I think, the new faculty of Social Sciences and Social Sciences. He asked for money. We approve this money. So money is there. Unless if you are telling me you did not know that there is money. But then too, this is your investment. Whether there was the money asked, you should have looked for this money. Because as the opponent said, what next? Supposing we give you this PhD. That's my next question. What are you going to do with yourself? Because I'm sure you are praying inside there. Said, I wish they can give me this PhD. What are you going to do with the PhD? If we give you? What are you going to do with the PhD? So you need to think seriously, because the other thing now, I go back to what we are taking note. I've seen the way you have written the abstract, and I don't think that is the way abstract is written. I saw what you have given in the book here. I think something is fundamentally not adding up. I think opponent has already highlighted that abstract you need to really revisit. You are telling us something about cassava. I get worried because you are saying there's a lot of cyanide in the cassava we have here. So why are you praising cassava to be a very good food when it kills? Somewhere it is in your abstract here, somewhere, that it is a lot of cyanide. So what do you want us to do? Because the question I had you saying, you said you went there naively. You didn't know what was in the cassava. Sure. The question now is, why did you go to sample from Nebi, of all places? The sample was from Nebi. That's what I saw. Why did you go to Nebi? There are 140-something districts in Uganda. So you must convince us why Nebi, of all places. The other thing I want to ask you, I think it is about I had the opponent talk about objective. Those objectives, to me, I think you need to revisit them. Number one is compounded. There are so many things. The objective is supposed to be smart. It should stand on its own. It should be specific, measurable, achievable, and then, of course, realistic and time-bound. Your objective, all of them, I think you need to revisit them. Now, number one is a mouthful. And to add the injury to what they call what? Injury to what? Yes. The hypotheses you put there, those are not hypotheses to me. And then the sentence, the tenses you are using. It is as if you are still developing a proposal. Remember now you are reporting to us work you have done. So I don't know whether you remember the English we used to teach us in the P5. It's not a reported speech, which means it cannot be future. It cannot be present. It can be what? You know it. So those tenses, I think, has implication, especially for a new PhD holder like you. I'm sure, as I told you, you are praying, we are giving you, we are going to give you. And then the use of ranges. All your thing you have reported, range. Sure? You are now a scientist. You pick 5 cassava varieties, you are telling us a range of this, a range of this. I don't think that is science. That's the mathematics we used to do in the primary. But now you are past primary, you went through what? Why did you decide to use your range? You are saying range this, range this. I thought we were interested into the significance of this work. I did not see it anywhere. And then towards somewhere, you talked about correlation being highly correlated something. What was the significant values there? I don't see the p-values in the abstract which I have here. I thought you need to put both. Because for us, what we are looking for, before even you said it is highly correlated, we first want to see the p-value. Was it significant or not? Because if it is not, then I don't see why you are deceiving us here. Huh? It may be there. Me, I'm working on the abstract you have given me in this book here. Not there. There, as you have told the opponent, you were smart. After you submitted a book, you were working. So meaning, we should first withdraw the mark we awarded you for what you submitted first time. Then we re-examine you. Don't you think so? So that we talk the same thing. The other thing which I thought you needed to convince us as lay people here. I heard you saying, these guys are all scientists. There are many lay people here, but they are farmer in their own right. And that's what they are looking for. For us, we're scientists, we know you. We know what you have done. But our product, or our output, or our whatever, is for the benefit of the lay people here. And they are very many. So what is it that the common person here should take home from your work? You have heard us being crucified as scientists. They said we talk languages which people don't understand. And exactly that's what we are talking. But the common person here wants something which is straightforward, clear. And I think that's why we are saying now people are demanding that research which we do should influence policy. Supposing you get out of here and you meet a policymaker outside there. See, I was listening, I was reading. What is it that now I can pick up as a policymaker? Because they're the one who decide where money should go. Huh? What would a policymaker now here pick from your work? Scientists, we have read the book, I don't know how many pages. A policymaker may want only half a page of this work so that he can go and fine-tune whatever to give to people who give money. So the people who are here, they are not scientists. You're asking them, I hope all of you are scientists. They are ordinary people in their own right. But they are coming to listen to what the doctor has now come out with so that they can pick it. Because they will not know about the science. Forget about that. Then the other thing which I thought was of interest. You said you used NASE 14. And this is where I'm interested. Where did NASE 14 come from? You should have highlighted the parents. The mother was this, the father was this, they was combined to give this, the reason is this. To me, I would be interested. Because in the future study, maybe somebody would now go and say, what can we do to also use it to bring out other cassava cultivars as you are talking. But I don't know, maybe it is in a book somewhere. The other thing which, of course, I thought you needed to convince me as a scientist. You are talking about the chemical composition of cassava. What is new there? Chemical composition of cassava. I've seen there's a table you presented there. In there, you have given us whatever. People have done work on cassava, and as the opponent has told you, I think now we need to see what new things you are adding to what people have done. You have not read in books where they have talked about chemical composition of cassava? Because now I think this is what you are telling us here. I'm sure this information is somewhere. So why do you devote so much of your energy there? And the other thing which I also had the opponent ask you, I'm asking you again. You highlighted the fiber, crude fiber, and then ash. To us here, what does it mean? Those ash which you highlighted, that they were very high in the improved, they were very low in the local. What is it? What do they do? And then the other thing, now, lastly, as I conclude, I think you should have been very smart. Did you take pictures to show us that you did some work? You should have shown us where you picked this thing, where you were suffering in the lab. If at all it is a suffering, you should have shown us the bread. And then you should have also brought a sample here, so that these guys would have been convinced you did the work. To me, I think this is a review which you did this quietly, and then you convince your supervisor here, said you signed the book. So where are the pictures? Show us the pictures of from stage 1 to the last. That's what will convince us that you did this work. But now you are giving us a literature review from a collection of things. Huh? I see the supervisor breaking his neck. I'm not saying that you did not do the work, but he should be smart, because they say seeing is believing. Maybe you see you sampling cassava in every there. We said, yeah, this is the man. In the lab there, you are trying to analyze those things you are putting there. We say, this is the man. And nobody will dispute that. So I hope those things are in the book, because I have not seen the book. And then finally, I think we want to thank you very much. I've been following your progress. I know at a certain point you were about to give up, but I'm grateful. You did not give up. Now you are there. So thank you very much. Maybe the only thing I should also say, but if I thank you, would have also not reached there. So I want to be able to drive you up to where we are now. Normally what I tell students, you are the boss. We are drivers. If you tell me where you want to go, we'll deliver you there. Make sure that you get there in time. We avoid accidents. So we are drivers. You are the boss. So thank you very much, and I hope you will pick it up from here. Tomorrow we want to see you a better person. Thank you.
Thank you, Director. Actually, I have come to realize when you are examining, you are having the same mind. Because almost all the issues that are raised by the two so far are the same issues that I have references. Why these ratios? So, John, yes, sir. So I request you to briefly, precisely answer What you can't answer, some are comments, you just acknowledge and we proceed. Please.
Thank you, Chair. What I captured here about abstract, that was a little bit answered. Maybe the significance will be done later. But cyanide in cassava. This thing about the cyanide has brushed my head for some time. We have different cassava varieties. Some have low, some have high, with the respect to the standards of 10 ppm to be in our flour. I've read reports from other Ugandans. Most of our cassava have hydrogen cyanide higher than the standard. And if we talk deeper, it would be, to encourage researchers at Narrow to bring up improved varieties with the varieties which are low in cyanide. And I hope, if we say it's high, because it is higher than what the standards do, and that research could bring us cassava varieties which get us also connected with the cyanide. I use with the tropical Atasic DRC in Tanzania, Malawi, and Zambia. We also eat cassava. If there is any connection, then the cyanide here should be taken care of. Why maybe? Maybe has been clustered under the cluster development projects by Ministry of Agriculture. It is known for cassava growing. So it was a given to do that. The rest I will check and improve on. Thank you.
Okay. I don't know whether he's convinced, but we can proceed. I think I can also pick myself of, because I was unexamined. And I'm guiding myself and for the rest of panelists. For the questions, in the interest of time, that have been asked already, you can jump them. John chose to work with bread in spite of so many other products. So I don't know what informed your choice of bread and ignore cakes and other confections. And in most of your literature review, you were glorifying the benefits of fermentation, remove the cyanide that the director is worried about, and produce a more safer and even a more tasteful product. So I wonder why you did not choose to ferment the cassava before you turned it into high quality flour. Actually, you have a lot of technical errors in literature. You cite some examples of vitamins, and then you say niacin, you comma. B1, I don't see the difference between niacin and B1. So I think you should always give enough time to proofread your work before you submit it. No one is going to blame supervisors for some of these technical mistakes. It's you. By the way, I have a curious question. We grew up knowing that when you are carrying cassava and it drops down by mistake, that food is going to be bitter on cooking. Where is the science? I don't know whether you have some information about that. You know, I was guided when I was doing my own PhD. At what age were the roots sampled? I couldn't find that anywhere in the book. And actually, as director says, when you get a copy of my book for corrections, all these things you claim, bread, the standard curves, the absorbance, should be part of appendices. And there are no appendices. This is the evidence the panel is looking for. You have to retrieve some of this information and add it to your thesis. The way you labeled your tables was very annoying. Because you are near the end of results and see table 1 coming back, and you've already given table 6. And I don't think saying sorry will help this examination. Here is a mistake. Actually, your mixed lab 2 curves are halfway. Because the tops are all cut off. And I couldn't see what would be the maximum level. I don't know whether you understand what I'm talking about. I will take you to see one example, but I think you know what I'm talking about. Mixed lab curves, they are halfway. I couldn't judge them fully. In the bread physical properties, you measured both bread volume and the specific volume of the same sample. I would like to know the difference between these 2 parameters. Volume versus specific volume. P-value is missing, that has already been said. Yes, please. Sister. These are questions that I think we needed to inform. I informed that introductory remarks that I am chair, but I was an examiner. And when we followed the guideline from graduate school, the chair is part of the panel. And being an examiner, I'm also entitled to, I examined this thesis. So these are questions for which we need answers. Now, conflict of interest would be chair and supervisor. I didn't supervise this work. And in the interest of time, maybe I can ask the candidate to, your recommendations should be enumerated, but you bulleted them. I think that's not very good enough. I saw some typing mistakes in the references, which we cannot accept before publishing this thesis. Like reference number 5. You give both names, small and big names. Is the Edgar Twine? I think this is not allowed. So you have to cross-check all your references. So, Mr. Candidate, me as chair and the panelist, intern examiner, would you like to respond to those now, briefly? Then we proceed.
Thank you, Chair. we are starting with the white bread. There's a quite a hefty consumption. We Ugandans consume a lot of bread. In a research by Kawski or something with they found that there is more consumption of bread in Uganda compared to other confectionery. So using bread as a drive for composite would be an interesting thing. You also asked why not ferment the cassava? Fermenting the cassava would be good. We would get a product which is not cannot be certified in East Africa because there is only something about high quality cassava composite flour or high cassava quality flour, quality cassava flour which is not fermented. We don't have any standard on fermented cassava. Come across. So if it's there, maybe we shall look for it later. Though that's why we did not want to ferment. But in some countries where fermented products are delicacies, like Indonesia, instead they use the fermented type. There is a curiosity why the cassava, which maybe is dropped, becomes bitter. Maceration of cells, it comes back again. Enzyme and the substrate. The linamarinase, which breaks down the linamarine, lotoshalin, stay in different components in cells. If they come together, they form the cyanide, they form all those things which people taste and say now the cassava is better. But the dropping is about the damage given to the cells where there was impact. That's what I feel it should be the best. Literature on rheology, that one I'll have to go and look into. Appendix, another thing. Tables, yeah. Mixolab curves. We took the major part of the curve. What is up is showing the curve for the temperature in the block or the temperature of the water. So what we need is that green curve, B curve. And you cannot use your eyes to see what is happening there. You can glance and see differences, but it is the figures they give of the torque they use for measuring protein weakening and maybe water absorption is given in figures. That's why what you only get. But with the use of eyes, you cannot see much of a difference. Volume versus specific volume. Specific volume is volume per unit weight. It also shows how porous a particular type of bread is, fluffiness, how good the fermentation was to show, to give a big expansion. And it tells you maybe there was enough extensibility and all those things, and the proper fermentation, incorporation of air, giving good cells, and things like that. That's what I can. The rest, I think I'll take care.
Thank you so much, John. I nearly got worried about gender sensitivity, but I think the next panelist was also an intern examiner, Dr. Phoebe. Briefly, let's not repeat what has already been asked. So we proceed.
Thank you, Mr. Chairman. Thank you, John, for your presentation. And I would like to thank Professor for that beautiful discussion. I read through the book, and what I'll say, much of which has been said, but I'll just point out what has not been said. In the methodology, John used local varieties, but in the discussion, he talked about, local and improved. Yes? But I would like to add sit and bitter so that we know which those varieties which were bitter. And then in the main discussant has also talked about the rheological properties. And in this discussion that I read, there is not much about the rheological characteristics. Then also, the first question that I'll ask, how do these rheological characteristics influence the quality of bread for the market? So since you did sensory and rheology, how do you intend to match the two? Show us how they are related and how you can improve the quality of the bread. Then another question that I would like to ask is, how do you intend to increase utilization of this bread? Prof has already talked about the common man, policy maker, industrial people who work in industry, regulatory authorities. How do you intend to increase utilization in the bakery? In what would be the take home for the common man, because bread is eaten and at a level of 40% substitution, what we want to hear is, what was your find? What did you do, produce? What was acceptable? And how does it improve quality of bread? So the rest of the things to correct that are in the book, those ones you'll find, I'll not repeat them here. Thank you very much.
Thank you, Dr. Phoebe. John, I think you briefly answered to these questions. Just to remind panelists that in the file there is a score form for scoring this session. So please check it out too. John.
Thank you, Chairman. I may not go systematically as the questions were asked, but the best take-home message is that we can incorporate flour from our common local material here into wheat to make bread. The costing is a whole different story. Utilization of bread in this country is likely to increase if we reduce the cost of bread. And this project is about reduction in cost. If a kilo of high quality cassava flour is 1,500 shillings. A kilo of wheat flour, the Azam brand I used is 3,000. If we could make it up to 30%, that would mean a significant reduction in price of bread, and then quite a number of people will afford. How do rheological characteristics influence quality of bread? It is the other way around. Rheology just measures the qualities of the composite flour. It is the amount of flour we add that will say that these characteristics resemble. Now we are using wheat bread or wheat flour as the standard. So everything we do, we must compare with the wheat. But in the findings, it was up to 20%. That is a given. 20% you can add. But when you go higher, you need to get flour improvers, some additives, which may again increase the cost of the bread. So at the moment, 20% is the best, the maximum we can go. But with the technology, only God can tell us where we will stop. Thank you.
Now your time, briefly.
Call it high quality. What qualifies it to be high quality cassava flour? Yet it is the one which you are still studying for its properties. It also affects the quality of the cassava, so that if another person used a different way of drying the cassava, they might not get the same results as you got. Then I also wanted to know, you finally chose a type of cassava, which you call a variety, which you proceeded with. Were the differences in the properties that you investigated between that one and the other types significant, or they were just close? And if they were significant, then would you advise that whoever is going to choose has to go through studying all that because the differences are major, or they were minor, that any other species of cassava that we might have might provide us with the same results? Then finally, you said that the cassava had high levels of cyanide. It has been hinted on oxalate and phthalate. What would you advise? How would someone first remove, because all the species that you studied had this high concentration of these toxic chemicals, they were above the recommended standards. Would you advise on how they could be reduced or they could be removed before processing the cassava, so that we get flour which has this in the acceptable limits? Thank you so much.
John, do you want to answer to those questions, please?
Yeah, thank you, Dr. Nanyonga. We start with the last, reduction of those toxic substances. Traditionally, people already do that through fermentation. But because maybe, I hope I won't be misquoted, because the Europeans came here and they did not ferment wheat to give bread. We think also we should not ferment our cassava in order to get bread. That's where the trouble, I think, comes. Here we want high quality cassava flour, meaning unfermented. You don't ferment it. You don't actually allow fermentation because you have to process it within 12 or 24 hours from harvest. That is the difference. And of course, with other quality determinations, which is in the standards of the East African. About NASE 14, which I shows, the differences are not much. They are not significant, but there is a difference. For instance, NASE 14 has a higher protein than the rest of the cassava varieties. No, the cassava cultivars. the opponent said now it is cultivars, not varieties, that I should stick to. So they are not significantly different, but the small difference in protein encouraged me, because the problem with the cassava is one of those, that there is very little protein. And the processing method I use is it was not designed by the researcher. We are using the process designed by International Institute of Tropical Agriculture from Ibadan, Nigeria, to produce high quality cassava. There can be a modification. There is one where they use pressing and you release some starch and other soluble products with the milk water. So in the final product, you have less carbohydrate because they have gone in the water. But here, there was no pressing. So we maintained all those solubles with the cassava. There has been also a bigger problem in this country, which actually triggered me even to do this research about high quality cassava flour. Processors out there are losing market with the buyers, like biscuit producers, Britannia, Reham. They produce what they call high quality cassava flour. When they bring them to the market, say, no, they don't meet our recommendations. And then you take it back. So the issue was, how do they make their high quality cassava flour? What is the mistake they are making? But I discovered that in most cases it is during the drying. They don't have artificial dryers. So it takes a longer time to dry, and within that time there's fermentation. And when they come, the pH is low, acidity is high, and they cannot use it in the biscuits. And this could also help to go and help the producers in the villages there, that, yeah, you follow the procedure. It was already given. And it's not creating a new wheel. Follow the procedures, and if there's a chance, a facility like Kava, Cassava Adding Value at Africa, and a big NGO supported by Bill Gates and Melinda Gates Foundation, buying these equipments for producers. These flash dryers are expensive. Our local people may not afford. So if we dry them very fast, there is no, and actually peel and grade very fast, there is no chance of fermentation. That one, which means down there you can do it. Or you can do it in some areas like Teso Sub-region or West Nile during the dry season, when it is very hot and dry. So within a day, if you can dry it, you may actually get good quality. And we are talking about varieties, cassava varieties, sweet and bitter. That, yeah, I will do that if I'm during the correction. But species representative, that is very, very difficult. I cannot do the research. I don't think even it has been done in this country. Gene mapping, that is what we would need to go around. For typical example, you are from Buganda. A certain cassava variety you call, I don't know, something. We may also have it, but call it a different name. But if there is gene, what do we call it, gene mapping, we would know actually they are the same variety. And maybe we don't have so many varieties in this country if we do that. So, and it will become very difficult to say, yeah, this is so much % of the varieties in Uganda. And in the book, there is also a study which was done by, is it Kizi or Kiz or somebody? He sampled a lot of varieties in Uganda, but unfortunately, he did not sample anything from West Nile. By then, we were belonging to the Republic of Belgium, Congo. We came back to Uganda in 1914, so we were left out. So it's very difficult. And now you confuse me. My agricultural knowledge is very small. When you talk about now species, variants, and cultivars, to say which is which, how do they the representativeness in Uganda?
Are you telling the examiner?
No, I'm asking. Give me a better chance, because I'm having a problem. I'm having a problem with that.
Thank you so much, John, for those responses. Now, we have two more panelists, and you'll really excuse me to ask Dr. Sio to ask hers, and then we end with Sam. Then the rest can ask a few questions. The candidate. Sanita is.
Thank you, Chair. Thank you, discussant. Colleagues, protocol observed. I request to remain seated. Mr. Manano, Ebenezer, that's how far God has brought you. Thank you for not giving up. Thank you so much for your presentation. It has been clear and elaborate. However, I have a few questions which I would like you to clarify for me. In materials and methods, you talk of NEBI, but you don't show us where NEBI is located, where you got the variety or culture, as the discussant said. And also you don't show us where ZADI is located in NEBI. I would request maybe you show us a small map of Uganda where NEBI is located, and then you expound on the map of NEBI and show us exactly where ZADI is located. When Professor Mugamposa sent me this thesis, I thought maybe it was a wrong version because I also didn't see the hypothesis. So when I saw the discussant mention it, I was at peace. As my colleagues have said, my advice maybe is we could give someone to proofread your book because there are a few mistakes, spelling errors that they can identify. You may not be able to identify, but they'll be able to identify for you and make those corrections. I was wondering, why did you choose rainy season for purchasing or harvesting the cassava? And why 10 months? Why not 3, 7, or any other month, 5 months? And then I was wondering why you chose Azam and not maybe Supreme or X, but that particular wheat flour. And then I was also wondering, I read through some parts which talk about the rural people are putting it in 2 use. They're using the wheat flour mixing with the cassava, but it has not yet taken up in urban areas. I was wondering, now that you have done this study, what criteria or measures are you going to ensure that it will be adopted in the urban areas, and the marketing approach that you'll use? And then for the control, you chose wheat 100% and cassava 0. I was wondering, maybe out of curiosity, why wouldn't you have also chosen cassava 100 and wheat 0? This study is a good one, and as per your recommendations, since, for example, we are importing mainly the cassava, the starch, to make tablets, why wouldn't you have also recommended maybe further study for people to carry out studies on this research, this starch, so that we can use as a country for our tablets rather than importing a lot of starch to make tablets? With that, I would like to thank you so much.
Thank you so much, Dr. Sio. Actually, your last statement is critical. When the president was here in our graduation 2019, he directed that we do research on starch and refined sugar. So I think as if you are going for postdoc, you may really think about this area. Would you like to answer to Dr. Asio's questions? Briefly, please. Precisely.
Yeah, thank you. When we start, let me start from the last. Why not substitute starch? At the beginning, this study was to include starch and high quality cassava flour, but it became unbearable because the pharmaceuticals, they won't give me any chance to test the starch I've given, whether it actually fits. I produced starch from the cassava varieties. I got all the 5. But nobody would allow me, and there is no MOU between the university and them to allow anything be done. And I just gave up. Even the packaging industries, we have one in after Mukono there, Riley, they're using starch, but I just wanted to test this native starch. Can it work for them? And nobody was willing. Time. When you ask this question, I hope management is also here to think of getting some MOU with the industry so that when we are doing something, we can go and experiment our products with them. Why did I use pure wheat as the standard? I think I talked a little bit about that. That Uganda, in the book, there was a long story about how bread came here. There was no reference. It was the researchers' information got during visitations to bread sellers. There is no exact date when bread came here, what quality the bread was. It is just going around assessing what type of bread do people buy. Does volume matter? Now, in this research, before we just came to about 60, I tried. Even the 60, I was trying for the sake, maybe something will improve. But when you put 60% cassava and 70, it just gives you a certain brick, a lamp. It doesn't expand. And there was no need now to continue with it because it won't help us anymore in the research. And that's the only thing we can have now. And we know if we had maybe rye growing around here, we could do that. Another question, how can we make it acceptable in urban areas? It will take something out of us all, the marketing, and to prove that actually it is palatable. You make the bread, you go marketing it, and unfortunately, most of us seated here are not good marketeers. Even if we were to start producing it in our beak, we may not succeed very much because we are not good at marketing. But with the good marketing and convincing the proprietors of, I don't know, Ntake, Shidawalime, and all those companies, maybe if they adopt it. Also, from the other angle, I would say this. If there was no wheat bread alone in Uganda, we would produce this and our taste would be adopted to cassava wheat composite bread. But because there was already wheat, it is the bread wheat we know as bread. So, I don't know, was there, why 10 months? That was actually a typing error. I discovered it also when I was reading. It should have been 13 months. And it is from information from the farmers, from Ministry of Agriculture, up to about 12 months. They are better. Most varieties are better, even the improved varieties. But after 12 months, the bitterness disappears. So that's when people, it should have been 13 months. I made a mistake, sorry. Why rainy season? The dry season gives water stress to plants. That's why the cyanide content goes up, because the plant is trying to protect itself and reduce all those. So we would in most cases get higher cyanide content than we have here if they were in a dry season. So I chose the rainy season to bring an idea that the best harvesting period must be when it is raining, Although the drying now will be a problem if you don't have an artificial dryer. But at least at that level, there is low. Maybe and ZADI. ZADI is Zonal Agricultural Research Institute. Development and Research. We have one in Arua. Even if I give you the map of Nebi, it won't appear. It is one in West Nile, in Arua district, supplying the whole of West Nile. So they bring those varieties to their client here, who should distribute the seeds now to people nearby. So this man they bring is the seed planter, and then the other people go to him and they get. But that map is interesting. Yeah? I hope I'll get it. And you see the map of Nebi with the sub-countries and some where they grow the cassava one day in some book. Thank you.
Thank you once again, John. We need that map. It's a recommendation. In methodology, where your samples came from, so it has to be captured in the minutes. It's not a choice. It's a recommendation from the opposition committee. So thank you for the responses, for the questions. Maybe to remind the Secretariat that we are required by the guidelines of the university to record the length of the viva. So we started at 10:25. Shouldn't be less than 1 hour, and at least I'm sure we have passed that. So next panelist is Dr. Samuel Gafuma. So engage the candidate, please. Sanitize.
Thank you, Chair. Thank you, our chief opponent. And then thank you, audience, for listening. John, my questions are about 4. And so far, I think the previous discussants and opponents have been a little bit more favorable. I may be a little bit harder, but it shouldn't threaten you. My first question, can I request that the presentation is put back? The presentation, eh? Yeah. Referring to slide 29 of your presentation under determination of physical attributes, so bread, you mentioned that bread volume was determined using the modified seed displacement method, where you used millet seeds. How did you account for the voids created during seed packing? That's the first question. And then, can we take this to be the true volume of the bread? And then another part of that, how would you compare if we actually used ground sugar instead of millet seeds? My second main question refers to data in your in table 4 on physicochemical characteristics of the high quality cassava flour and wheat flour. The question is, if you can go to table 4, what implications does the high water binding capacity observed in cassava flour have on its dough making capabilities? And I think that also references to the water absorption capacity. Then my third question, if you refer to table 5 of your results again, the next table. Yeah, knowing that cassava flour has no gluten, how do you explain the increasing glutinous behavior of the composite as the content of cassava is increased to 100%? And my last question, again, goes to your background in where you had figure 3 about Uganda cassava export quantities. How does these export figures fit into your study? That's all I have. Thank you.
Thank you once again, Dr. Gafuma. So John, these sound really like hard questions, but there is a program on CNN. It's called the Hard Talk, but we who observe it enjoy it. So just take it calm and please respond. these questions. John?
Thank you. It's easier. You know, the last question is still here, stuck. Cassava export. It fits because we are here saying in Uganda we produce a lot of cassava. We are number 22 in the world. The domestic market cannot absorb all that. If we can export and not export sliced roots, fresh roots, and if we can export high quality cassava flour, that is added value and money coming in to boost our foreign reserve. So in this, it may not be a recommendation or a specific objective to study, but because it will now involve how much is going we spend, but it is important. This information will encourage people if we really organize the export system well. Farmers will gain, middlemen will gain, transporting and exporting, and all of us will laugh, especially those who are dealing in cassava. Gluten index. These are Mixolab indices. These are parameters measured by the Mixolab equipment, and it is converted into indices. Very difficult to explain also because it's the software converting it. But what is asking is about the gluten here. We are here, pure wheat, 10% cassava, 20%, 30%, actually 40%, 50%, and even 60% shows similarity because there are no difference. The difference is at plus minus 2. So they are the same. But now the question is asking is at 100% cassava flour, why is it high? Cassava does not have gluten. And here we are looking at gluten behavior when it is being heated. I don't know, I was going to use a very strange word because in science I don't think that word we would. But cassava starch when heated behaves as if it is gluten. You know, the viscosity it gives, you may think gluten has been formed in that cassava. The stickiness, able to resist some, I don't know if you're cooking food, maybe cassava itself with a lot of starch. The water can, you know, it gets sticky. So that is the behavior, the characteristic the Mixolab takes up. And you may think you have gluten, but you don't. It is only the behavior of another component in the flour which shows that you have gluten. It can deceive you. Another thing is water binding capacity. Water binding capacity, we see here cassava flour, high quality cassava flour has all of them, irrespective of variety, very high ones compared to wheat. Their water binding capacity. And wheat has 87, and here they are very high. Water binding capacity is affected by the starch. We have quite some starch in cassava compared to wheat. It will absorb the water, which means it will influence the water absorption of the composite. Now, if we don't control, if we do not know, it needs a good breaker to know up to what level actually should allow water, how much water should add, because it will interfere with the consistency of the dough. And because there is cassava, water absorption is high, you may end up adding more water and the dough cannot hold the gas being formed, and then you won't produce any good bread. You will produce flat bread because it had become very extendable. The gas escaped during fermentation and kneading. So It is water binding capacity is important in the formation of dough and in dough consistency. Volume measurement. Why millet seed? Millet seed compared to brown sugar. Ground. Maybe we could extend it further. Have we measured the particle size of the ground sugar? If we have, we would know what sizes of the ground sugar is. And then we would know the packing density. If it packs, if the particles are smaller, they have a higher packing density. They'll pack better than millet. So they will show you a better volume than millet. But if they are the size of millet, there will be no difference. Or if they are bigger than millet, they will be actually showing you worse results than for millet. And I also don't know how, I've never tried to compare the hardness of the ground sugar compared to the hardness of millet. Because we don't want these seeds to deform when we are measuring volume. No breaking, no deformation. If they deform and break, if the flour becomes flour, I mean the ground sugar is flour, that is not so very comfortable to use it in measuring volume. But either way, we are estimating the volume. There are equipments today in the developed world which is used for measuring volume. These techniques have already been abandoned. We are still using them in banana republics and third world countries. Thank you.
Thank you once again. I cannot really request you to clap for you because at least you are doing quite good. As if I saw the deputy director. I think he has left. A quick announcement as we head into questions from the public. We have lunch for everybody. So please, after the session, get your coupon from Madame Stella. I don't know where she is. She's behind there. So you have lunch in the cafe. Just here in the corner. Okay, thank you. Now, if some questions from the public, Dr. Stakawa has already gone, and how do we proceed? 1, 2, 3, 4.
Thank you, presenter, Mr. Manano. I have 2 questions. Thank you, discussant, ladies and gentlemen. Do you have a patent from this work? Because I realize it's very important work. You're dealing with the food item. One of the examiners asked you what rheological properties do you have on the bread. I think another question came in that you do have work here. You were scared and said we cannot market. There is Turkey, there is everything. We cannot do anything. When you changed those ratios, I expected you to come up with one ratio with high improved bread. Of course, you know the wheat bread is very expensive. No bread is below 5,000. Sure. You get bread which is not good bread. It's a feathery. It just breaks. It's nothing. But you don't have any bread you are giving us. And yet we are customers here. I would be number 1 actually to buy your bread. You live in the same community with me in Amylase. You know the bread we buy from those local people. This should be now your chance to exploit, and we have something for us there. Yes, so actually this work should progress. We don't want this work, your dissertation, it's just kept on the shelf. We should be so more practical in real life. The second part is on specific objectives. You are saying you used roots, cassava roots. I know cassava has roots and also has tubers. Did you really use tubers or roots? What's the relationship between you using roots and your composite? Why did you choose the roots and leave out the tubers? Thank you very much.
Yes. The first question is commercializing this. Patenting, even whether we don't patent, if we could commercialize it, would be good enough. But this is not just a question for me. Most of us in the academic world are poor investors. We like doing this type of thing and we keep quiet about it. That is a big challenge. It's a big challenge for me. It's a big challenge for you. I don't know. Or you are actually challenging me to start it now. I saw Dr. Nyende of chemistry here. I should go for consultation. Okay, thanks. Then the second question is about why did I use roots and not tubers? That takes me back to the definition of roots and tubers. Cassava are tuberous roots, they are not tubers. Because if we look at the at tubers, we take things like potatoes. We normally call them Irish potatoes, but that does not exist in literature. It is potatoes. Ours is sweet potatoes. Tubers have the capacity to grow young ones from them. They have eyes, something can sprout from the eyes. With the cassava roots, nothing can happen. Tubers store a fruit for the, this in biology and agriculture, there is that difference between tubers and roots. So, but cassava is a root by definition from its characteristics. So we are using roots. It is not a tuber. I'm not going to, you cannot use tuber here.
Thank you, John, for the presentation. I have one question with two parts. You stated in your introduction that cassava is grown in most parts in Uganda apart from Karamboja and Kigezi. When I was in Karamboja in 2001 doing field work in Kidepo National Park, the most dominant crop around that park was cassava. Second part, in Kigezi as early as 42 years, 1979, in sub-county of Rwamchuchu, in the current district of Uchiga, already cassava was already going there. So I think that information may not be accurate. Thank you.
Thank you very much. Yeah.
Thank you. I will go with that. Thank you. I would have had two questions I will ask them. One, if you go to table 10, I'm somebody who has a lot of interest in figures and why they appear there. Yes. If you look at those error margins, they are relatively big compared to the actual values you're interested in.
Yeah.
Largely meaning that all those values are actually rejectable if I actually go for the upper limits of those error terms. So that means your mixture compositions are actually unattainable. So why would somebody do that? That's one. Because when you look through all that, you'll be crossing to a different level and the error margins are very big. Two is a little bit easier for you. When you come to defend your doctoral thesis, you're defending something which is close to finished. Why, in your view, did you change objectives away from what you submitted and now you are presenting something? Is that work in progress or you had finished that work? Thank you.
For the first question, I need consultation with the statisticians. So to talk when they talk about large error margins and small ones, I know these from the latest statistics I came across. I was arguing that actually even the 30% and 40% can be acceptable if we add scores. We can get things before after more than 5, which would make the composition acceptable. Acceptable from the sensory aspect. not necessarily it will survive in the market. But the science here will say, oh yeah, it's neither like nor dislike. It is at the borderline. The change was in the objectives was because I overlooked certain things and the work was done, but mistakes are made and we continue correcting them. Even after correcting this one and submitted, it can be corrected again. It will never stop if you are still interested in upgrading your thing. Thank you.
Thank you very much, Mr. Chairman. I beg you permit me to talk while I'm seated. Thank you very much. Mr. Chairman, this is a public defense. Therefore, allow me to represent the public so that I speak as a layman, not the food scientist in Hadija. John, thank you very much for the study. Cassava being the second most consumed food in Uganda, or the second step next to banana, it's worth being researched, and value addition is very key. When you search on the Ugandan market, for example, here we are talking about substitution to 30% in bread. But you can also look at other confectionaries. You can make cookies 100% from cassava. And this should actually, you could put this in your conclusion or recommendations, that whereas we go up to 30% substitution when it comes to bread, other confectionery products like cookies, like scones, like biscuits, like crackers, you can have a 100% wheat product cassava product without wheat, thanks to the good quality of starch in the cassava. So what the Ugandan farmers and producers need to do is to invest in producing the high quality starch. And you know what? You can, on the Ugandan market here, if you go to industrial area, you can acquire a cassava grater at 2 million, a pressing machine at 1 million, and you can fabricate a solar dryer using plastic at around a cost of less than 1 million. So with an investment of around less than 5 million Ugandan shillings, a Ugandan producer is actually able to package high quality cassava starch that can be used in the production of other confectionaries, and even the starch could be submitted to those other good industries that you want to do modification, and therefore it could qualify to be used maybe by the pharmaceutical industry, the paper industry, the textile industry, and many other industries. Okay, away from being the public person, now let me come back to the scientist in me. One of the main challenges of cassava is the nutritional content. Much of it is actually more of carbohydrate, and it has less of the other nutrients. So if you're to promote its consumption as a food security material, then biofortification would be handy. So I also hope that in one of your recommendations, you could recommend the cassava, your most favorite cassava variety being biofortified with some of the most essential nutrients, especially nutrients like iron, zinc, so that it could be very, very nutritious for the final user. Thank you very much.
Yes, Madam HOD that is a very good comment, and we are in a poor third world country. I've read about biofortification in Nigeria, attempted, but not widespread. And also, we have to look at the contradictions in biofortification. If you biofortify one or two varieties, and one day they are attacked by diseases, you will leave us at the mercy of, I don't know what, at Monsanto or who. So people have tried it. In Kenya, there is a yellow cassava. The genes, there was a gene modification so that it could accumulate more beta carotenes, and it is yellow cassava. You ask yourself, are the Kenyans eating the yellow ugali, or they have discarded it away? So yeah, after that we need sensitization that we are doing this for the good of you. If we could go to Bushenyi. I knew of yellow potatoes from Teso. They went to Buchenyi and sent a lot of vines modified to produce yellow potatoes. I don't know how the yellow potatoes and the acceptability there and the adoption is doing, but all those things are good things. But at the moment, we should not cry so much. There is a law. I don't know whether we have food law or just regulations in Uganda. All flour, and by flour, I think now we consider that as wheat flour. All the flour in the market is chemically modified with folate, zinc, iron, and I don't know, maybe another vitamin A, something like that. So if you are a commercial producer of cassava flour, I think you will have to comply. Chemical fortification. There was an NGO here whose workers retired, so it was helping us. So that's a good comment.
The physical public audience for those questions. Now we have 2-3 questions from the online audience, which we will have to respond to, then we close this session. One is from Julius, who is on Zoom, and is wondering what is the reason for focusing on rheology of only NACE. I don't know if you will have an answer for that. I'll read all of them so you answer at once. Then his second question is, from your recommendations, only 20% composite can be successfully used for bread making. So he says, what does this translate into? Is it economic? Then we have another. He's wondering if the physical-chemical properties of soil where cassava is grown would have an impact on secondary metabolites, which you determined in the study. And the last one is from Dr. Mwonge Abaka. Where do you go where do we go from here now? Where do you want to take the work after this session? In other words, how are your findings also going to help your mother in the rural village? And also, how can the findings inform the cassava breeding strategies in Uganda? Lastly, if you were to repeat this work, what would you do differently? So thank you so much. And you answered those, and we close this session.
Where do we go next? Now that takes us into politics. Yes. Policies are formed by politicians. We can only help. If 20% is good enough and it is economically viable, then we could introduce a policy where we imitate the Nigerians. Compulsory 20% cassava inclusion in wheat. And justify it because there is a source here of information. And also, we protect boo-boo. We have all heard about boo-boo, haven't we? Buy Uganda, build Uganda. If we are serious on that issue, we can. What next? About research. I don't know whether this can help policies in releasing money to narrow, NACRE there. That we get cassava, which is low in cyanide, so that actually safety does not become any problem anymore. I read some publications from Thailand. They have cassava with about 6, 7, 8 ppm of cyanide, and you wonder, what are they doing? soil. Uganda is divided into different agroecological zones. And when they test this cassava, I'm not an agriculturist, but maybe they would better explain. But when they get this cassava from Kawanda, they go and test them in these different agroecological zones. Taking for us NASE 3, NASE 14, NASE 19 and the rest, which means they have tested them there and show that they can survive there better and produce well. But definitely the conditions of the soil, the environment matters a lot in the composition of the final product. Economics. Here it showed 20%. As I was talking with the opponent here, I ran short of finalizing the economic implication, because if we go and introduce this into a bakery, there must be also capital investment. The mixing, unless we are getting ready-made blends from somewhere. But even in a ready-made blend, the flour producer must purchase an equipment to blend cassava and wheat in the percentage we want, and maybe add on improvers and all other things, the cost of which I don't know. So the final economic implication is very difficult for me to answer. Why rheology of NASE 14? It was just a sample of the different cassavas, and I said, I looked at NASE, it had a slightly higher protein, and we know, as our HOD was commenting here, nutritional issues, the cassava is the major problem. If we could also biomodify cassava, the thing is biomodify, that the cassava roots can accumulate more protein than it does at the moment, would be a very good thing. But do we have the money? Do we have the technology? Those are the issues. Thank you for those.
So, colleagues, ladies and gentlemen, allow me to appreciate John here, Mr. Manano, with a big round of applause for the job well done so far. We also extend that appreciation to the panelists, to the physical and virtual audience for being very patient with us. It looks like it has been a bit long or lengthy, but you agree with me that we really wanted to satisfy ourselves that you did this work. So I think it is okay. At this moment, I really thank you. I'm not congratulating you for the last one, but congratulating you for successfully presenting your work to us and for answering questions from the examiners. We hope they will be satisfied with your responses. Now I request you and the rest of the members to step out in order to allow for a discussion with the opposition committee or panel of examiners on the outcome of this session. After we have reached a consensus decision, then you will be invited back, John, and any member of the public who may be interested, back to this room for announcement of the results. Thank you so much. You may wish to give a round of applause to the chair for... Thank you. Colleagues, I think lunch could be ready, Stella. So maybe members wish to use this time to check in for lunch as we deliberate on the outcome of the session. Thank you. Lunch is in the next room, I have been informed.